If your home gets a very high voltage from the power company, say over 130 volts, some of your appliances may be damaged. There are devices such as battery chargers, LED lamps, and others that often fail when permanently exposed to excessive voltage. It is not always easy to solve this kind of problem. It is best to try to lower the voltage with a special transformer. Here another problem arises. If you want a transformer that covers your entire house, you will need a huge and costly transformer. What to do? You can put together a simple low-cost voltage reducer using a small transformer for lowering the voltage for your appliances. What you need is a transformer of the type called filament transformer, normally used in battery charging and other tasks that require a low voltage, say 12 volts. These transformers are very similar to doorbell transformers, but they have a bigger capacity. This drawing shows a typical filament transformer. On the left side of the drawing, you can see a pair of wires connecting to the inside of the transformer. They are usually black and go to an internal winding called primary. On the right side of the drawing, you can see some wires also. In this case, there are 3 wires. One of them is black, the other 2 are green. The green wires in this drawing go to a winding called secondary. If we connect an AC plug to the wires going to the primary winding, a voltage that depends on the transformer step-down ratio will appear at the output of the transformer, that is, on the secondary winding green wires. In our case, we need to get ourselves a 12-volt filament transformer with a current carrying capacity of about 2 amps. To use our voltage reducer, we must connect the filament transformer as shown in this drawing. The primary winding, black wires, is normally connected to your wall outlet. A voltage will appear in the secondary winding, green wires, which will be 1/10 of the line voltage. For example, if the voltage in your wall outlet is 130 volts, the voltage that will be at the secondary winding of the transformer will be 13 volts. If we now connect the current from your wall outlet in series with the secondary winding with a certain polarity, the output voltage from our reducer will be equal to the sum of the voltage of your wall outlet plus the voltage produced by the transformer's secondary winding. This will give us 143 volts, which we do not want. We now reverse the wires of the secondary winding as shown now. The resultant voltage will be equal to the voltage at your wall outlet minus the transformer's secondary winding voltage. This will yield 117 volts, which is what we do want. You must install an outlet to output this 117 volts to the device you want to protect. Both the transformer and the outlet must be encased inside a plastic box, and our reducer is ready to be used. Simply connect it as if it were an extension cord. Warning: you cannot exceed 200 watt loads, because the transformer can overheat if you drain over 2 amps from the secondary. If you need to fit higher wattage devices, you can use a 12-volt transformer with a higher current carrying capacity, say 5 amps or more. It's better to experiment with low loads at the beginning and then expand the system. I hope this video is useful to you. Thanks for watching and please subscribe to my channel. Ciao Tarin.